Let's look a little bit more at debugging. I know that the kind of debugging with a kind of a print line or something like that is something that people that use more advanced IDEs scoff at, right? They have their fancy graphical debuggers. You can actually get that in Julia as well. If you're using a VS Code, for instance, Julia has a graphical debugger that you can use. But I want to show you that even if you're using text mode Julia, just using the terminal, you can actually get a fairly good debugging experience. Using a text mode debugger doesn't actually have to be that bad. And I just want to show you a little bit, give you an impression of actually the workflow that you can use with the text mode debugger, and show you that's actually probably better than what you would expect. Let's say that we want to be debugging parse Roman. How will we go about that? Well, we're going to use the debugger package. And the way we start that is with enter, and then, okay, let me just do, this is the one I want to debug. So, okay, right, enter in the beginning, and this will run this code with the debugger. Debugger is going to be a bit slower because debugging is actually working more like Ruby or Python. We're actually interpreting Julia code. Usually Julia code is running through a just-in-time compiler, which is what gives Julia, despite being this dynamic language, you're actually getting a C or Fortran or C++ kind of performance in Julia. With this, you're actually going to be typically dropping below what's the kind of performance that you have in Ruby or Python. So a couple of things that you can notice here. We have switched mode. This is the kind of cool thing in Julia, right? The debugger package is really just adding another mode to your Julia. And you can get all sorts of modes. There's even modes for Lisp style Julia. So you can write Lisp expressions in Julia. So you can see here we have marked off what is the current line we're at. So if you do N for next, you can see that that moves downwards. Now we're at 13. You might not know that you're using N for this, so if you wanted to find that out, it's question mark, and this gives you a list of all the stuff that you can do here. And so you can find here step to the next line, and you have things like step into the next call, continue execution. You can do plus and minus to show more lines of code. This is useful to show the current status, and then backtrace. This gives you the backtrace where we're currently at, st the status. We can use it to get the plus here to get some more lines, or minus to get fewer lines. Let's just get a little bit extra lines. And then we have fr to look at the current variables that we have. We have the s is contains this, and the x is currently 0, so we can do an n here and see how that develops over time. So what does it look like now? Well, now you can see that the x has become 1. Now it might be that you want to actually look at, where's this in my source code file. And then you have the O for open that takes us to that location. I can repeat that. I can just close this one, and you can see that it opens my text editor at that position. So it's very easy to go back and forth like that. Okay, so let's say we want to debug and we want to have set of breakpoints. We want to stop at different places in the code. We can do that. We do enter as we just done before. Now let's expand that a little bit so we can see some more lines. And now maybe I decide that, okay, I want to have a breakpoint at line 17. I can do then BP add 17. And if I want to get a full overview or all where all my breakpoints are, I just write BP, and you get a list of that. Of course, now I just have one of them, and I can, of course, use the trick with commands click to see where my breakpoints are. So it's, even though we're working in the terminal, we can very quickly go back and forth between our text editor. So we have the same kind of advantage as we have with an IDE, in that we can go between different tools easily, even though they're not really integrated. Let's continue, and you can see now it stops at that breakpoint. I can look at what things look like that. You can actually go into different modes in debug. So if I do backticks, I go into Julia mode, but I'm currently in the stack backtrace of the debugger. if I write X, I get, what that it's saying there. But anything that's valid Julia code I can use here. I can just write hello if I want to. I can assign a different value to X if I want to. Anything is really possible here. I can look at what the S looks like. Or we can just continue again. We hit the breakpoint over, continue, and so on. And we get the final results. Of course, it got screwed up because I changed the X value. So this means that it's actually very nice debugger in many ways to use, I think, because you can actually write extra code that you can use while you're debugging. For instance, that maybe I want to analyze some of the data or show it in a particular way while I'm debugging. I could just define a Julia function that displays that in a particular way. So let's just a very simple example of that. So here you can actually see my breakpoints, right? So that's kind of nice. You can continue, and maybe you want to look at S, but maybe you want to display it in a kind of different way, and you define a particular function for that. Now I'm just going to make it simple and say that that's lowercase. Of course, it already exists, but right, I can do lowercase like that. So you have the whole language available, which means that you can amplify your whole debugging experience by just creating your own special functions that you're really just utilizing for your debugging experience. You can put those in a particular separate package, and you can just load that package up and use it when you're doing debugging if you need special kind of functionality that's practical while you're debugging. And what's cool is that the debugger, you don't necessarily need to just debug the stuff you've written. You can use it to debug anything. So maybe you wonder, how does actually this get executed in Julia? Well, you can just enter that and see how that works. So now we're stepping in. So I'm going to step in here. So I do an S and I step in, and you can see kind of how a bit of how the Julia machinery dealing with numbers is working. So there's quite a lot of stuff, right? When you're just adding two numbers, it's doing all this promotion and conversion to make sure that the same kind of numbers. So I'm just gonna go. We can do the FR here to see what it looks like. We can do the backtrace. So we're going through a whole bunch of stuff here. We can just continue that. You don't have to look at all that. It might look weird when Julia's doing all these different things when you're adding two numbers. How is that very effective? Well, here's another cool thing you can do. You can do code native, and you can see how Julia turns that into machine code. I think this will surprise you a little bit. All of this stuff here, that's just comments, so you can pretty much ignore that. These are the actual lines of code that you find here. So this is a machine code. These are individual instructions to the central processing unit, the CPU. And the first one here, that is really just converting the integer number to a floating point number, and then we're doing a floating point addition here. So that is as small as you can do it. You couldn't get it better than that in C or C++. This is just return from the function. There's no way of doing that simpler. I can do, say, 2 plus 3, and again you can see that this is just an individual function being done here. We can do all sorts of more complicated expressions, of course. Let's see, divide that by 4 or whatever, and these gets really cut down to size. So that gives you a little bit of a very brief impression of just how the Julia just-in-time compiler can take actually quite complex Julia code that looks very dynamic and just smash it into a couple of instructions in machine code.